Welcome back to my chemistry lessons. Today we are going to discuss about the equilibrium constant. So when we are going to define an equilibrium constant for a general chemical reversible equation like A plus B gives C plus T, it's a reversible. So that means reactants can be converted into products and products can be converted into reactants. So according to law of mass action, the rate or speed or velocity of a chemical reaction is directly proportional to the product of active masses of reactants. So that means a rate of a substance in a chemical reaction is directly proportional to its active mass. So what is meant by an active mass? Generally, in equation, we represent active mass in a closed square bracket. For example, here, active mass of A is represented like capital A in a square bracket. So that means the molar concentration of the reactant A, or the gram molecules of reactant A or any reactant substance per liter of solution. So according to law of mass action, the rate of a chemical reaction is directly proportional to active mass of reactants. So here there is a general reaction A plus B gives C plus D. So here the forward step is A plus B converted into C plus D as a product. Now reverse step is the decomposition or the conversion of C plus D into reactants A and B. So rate of the forward reaction means is equal to, according to law of mass action, is equal to a constant multiplied by or the product of active mass of reactant A, active mass of reactant B. So rate of the forward reaction is equal to K1 is a velocity constant. K1 is a velocity constant. The product of active mass A and B. So similarly, the rate of the backward reaction, that means backward reaction means decomposition of products into reactants. So here rate of backward reaction is equal to another constant K2 and the product of active mass of C and D, because in that case in that case C and D are going to decompose into and B, means that's opposite of the forward reaction. So that is about the law of mass action. So next step we are going to derive a mathematical derivation for equilibrium constant. So we consider the same general equation A plus B is equal to C plus D. So the equilibrium constant Kc, normally it is represented by Kc. So according to law of mass action, when we apply the law of mass action on above equilibrium reaction, the rate of the forward reaction is proportional to the product of the active mass of reactants. When we change the proportionality into equal, we'll get equal to a constant and the product of the reactants, active mass of reactants. Similarly, the rate of the backward reaction is equal to the rate of the backward reaction is directly proportional to the product of the active mass of reactants in that case. So here is the rate of the backward reaction is equal to K2, the product of C, active mass of C and active mass of D. At an equilibrium state, as we know, the backward and forward reactions are taking place at same rate, but that never be stopped. That's why we call it as a dynamic in nature equilibrium. So my point is, at an equilibrium, the rate of the backward and forward reactions are equal. So at equilibrium, the rate Rf is equal to Rb. That means Rf is equal to K1, the product of the active mass of reactants A and B, and K2. So this means Rb is equal to K2 and the product of active mass of C and T. So when we move the K2 into left hand side, we will get K1 by K2 is equal to another constant that is known as the equilibrium constant, Kc, is equal to the product of active mass of products divided by the product of active mass of reactants. So in that case, equilibrium constant Kc is equal to the product of active mass of Cd divided by the product of active mass of reactants A and B. That's about today, and I hope you enjoyed this. Thank you very much, and God bless.